Hey everybody, welcome back to the Build Show Network. Steve Baczek, architect here, and I'm just going to jump out and let you appreciate the view from our Hilltop Aero project. You know, we're on the order of a 14-foot slider here in this wall. We have just a couple feet on each side. Now, architecturally, everybody wants to fill up the walls with glass, but the reality is that we need a little bit of wall to resist things like earthquake and wind load and shear load and all these things. We need to be able to have a stiff building with glass, and we can't rely on the window unit to provide any of that resistance. It has to be taken up inside the wall. So when I was designing this project, the question was, how big does this door come? Because the wider we make this door, the harder it is to structurally resolve this wall due to the shear values. And so what you can see here is we have this corrugated metal in here. And what that is basically a Simpson strong wall. So it gets bolt anchored down at the bottom, it gets bolt anchored up at the top. You see there's one on each side, and basically they provide the bookends, and they keep the wall from wanting to do this in the wind, or in the case of an earthquake here, basically racking. So they provide that moment connection or that stiffness to keep these two corners upright so that we can put this large window, or in this case sliding glass door, in that opening and appreciate that view without worrying about our house getting blown over. So let's jump back to the studio. We'll pull out some drawings and we'll talk about this a little bit more in depth. I'll see you back there. Hey everybody. Hopefully you enjoyed that nice little clip of video out at the Hilltop Aero project where we talked about a big wall with a big window and little itty bitty sidewalls. But we're going to let Big Red go rogue this week. So we don't have any backdrop of details. We just have blank white paper and a red marker. So let's see what he's got up his sleeve. And let's talk about shear walls and lateral loads. We got Big Red, and like I promised you, we got a blank piece of paper today. So let's talk a little bit about lateral loads, shear walls, all that good stuff, what it is. This is Basics 101. You like that, huh? Basics 101. So let's say we had a wall. In that wall, we had a bunch of zip panels nailed up. They're all nailed, right? And that wall is connected to a foundation wall. And you have the ground here. All right. So, lateral load is nothing more than a load that's being imposed on the building laterally, right? As opposed to a gravity load, which is one of the ones that we're very easily solved for, right? Building applies a certain load gravity. We provide a resisting force at the foundation. Building stands up. But what happens when the building gets that load laterally? Well, the building wants to deform, right? Or it wants to deform this way, depending on which way the load is laterally being imposed. Now, down here, we have the ground. So when this pushes, the ground is pushing back here, and when this pushes, the ground is pushing back here. But the top of the wall isn't, right? So how do we get stiffness in that wall or a resisting force to that lateral load? Well, nailing up these panels makes them a structural shear panel, and those in composite action of all those panels then fight back on those lateral loads and the building stands up. Well, that's real easy on a garage wall. Don't have any windows, any of that. But the minute I start poking holes in here, then my shear panel starts to dwindle.